The recommendation problem considers a set C of users, a set S of items. Let U be a utility function that measures the usefulness of an item S to a user C. The utility is commonly represented by a rating, and it is initially defined by only for items previously rated by the user. For example, when joining a movie recommendation system, users are typically asked to rate several movies. The space C multiplied by S of all possible users and items is huge. The recommendation system should be able to extrapolate from unknown ratings so as to predict the item user combination. Items with the highest predicted rating for user are recommended to the user. The memory-based methods essentially use heuristics to make rating predictions based on the entire collection of items previously rated by the users. That is, the unknown rating of an item, user combinations can be estimated as an aggregate of ratings of the most similar users for the same item. Typically, a k nearest neighbor approach is used. That is, we find k of other users or neighbors that are most similar to our target users, u. Various approaches can be used to compute the similarity between the users. The most popular approaches use either Pearson's correlation coefficient or the cosine similarity function. A weighted aggregate can be used, which adjusts for the fact that different users may use the rating scale differently. Model-based collaborative recommendation systems use a collection of ratings to learn a model, which is then used to make rating predictions. For example, probabilistic models, uh, clustering of like-minded customers, Bayesian networks, and other machine learning techniques have been used. The hybrid approaches integrate both content-based and collaborative methods to active further improved recommendations. The Netflix prize was an open competition held by an online DVD rental service with a payout of $1 lakh for the best recommender algorithm to predict user ratings for films based on previous rating. The competition and other studies have shown that the predictive accuracy of a recommender system can be substantially improved when blending multiple predictors, especially by using an ensemble of many substantially different methods rather than defining a single technique. Data mining for financial data analysis. Data mining is a relatively young discipline with a wide range of applications. In financial data analysis, most of the banks and financial institutions offering a wide variety of banking, investment, and credit services to the customers. Some also offer insurance and stock investment services also to the customers. Financial data collected in the banking and financial industry are often relatively complete, reliable, and of high quality, which facilitates systematic data analysis and data mining. The first one, design and construction of data warehouses for multi-dimensional data analysis and data mining. Like other applications, data warehouses need to be constructed for banking and financial data. Multi-dimensional data analysis methods should be used to analyze the general properties of such data. For example, a company's financial offer may want to view the debt and revenue changes by month, region, and sector and other factors, along with the maximum, minimum, total, average, trend, deviation, other statistical information. Data warehouses, data cubes, the characterization and class comparison, clustering, and outlier analysis will play an important role in financial data analysis and data mining. Loan payment prediction and customer credit policy analysis. Loan payment prediction and customer credit analysis are critical to the business of a bank. Many factors can strongly or weakly influence the loan payment performance and customer credit rating. Data mining methods such as attribute selection and attribute relevance ranking may help identify important factors and eliminate the irrelevant ones. Classification and clustering of customers for targeted marketing. Classification and clustering methods can be used for customer group identification and targeted marketing. For example, we can use classification to identify the most crucial factors that may influence a customer's decision regarding banking. Customers with similar behaviors regarding loan payments may be identified by multi-dimensional clustering technique. This would help identify customer groups, associate a new customers with an appropriate customer group, and facilitate targeted marketing. Next one, detection of money laundering and other financial crimes. To detect money laundering and other financial crimes, it is important to integrate the information from multiple heterogeneous databases. As long as they are potentially related to the study, the multiple data analysis tools can be used to detect unusual patterns such as large amounts of cash flow and certain periods by certain groups of customers. Useful tools include data visualization tools, linkage and information network analysis tools, classification tools, clustering tools, and outlier analysis tools and sequential pattern analysis tools also can be used. These tools may identify important relationships and patterns of activities and help the investigators focus on suspicious cases for further detailed examination. Data mining for retail and telecommunication industry. The retail industry is a well-fit application area for data mining since it collects a huge amounts of data on sales, customer shopping history, goods transportation, consumption, and service. The quantity of data collected continues to expand rapidly, especially due to increasing availability and popularity of business conducted on the web or electronic commerce. Today, most major chain stores also have websites where customers can make purchases online. Some businesses, such as Amazon.com, exist solely dependent on online without any brick and any mortar as a rich source for data mining. Retail data mining would help and identify the customer buying behaviors, discover customer shopping patterns and trends, improve the quality of customer service, achieve better customer retention and satisfaction, enhancing the goods consumption ratios, design more effective goods transportation and distribution policies, and reduce the cost of business. Practice for retail industry. Design and construction of data warehouses. Because the retail data cover a wide spectrum of items, there can be many ways to design a data warehouse for the industry. The levels of detail to include can vary substantially. The outcome of preliminary data mining exercises can be used to help guide the design and development of data warehouse structures. Second, multi-dimensional analysis of sales, customers, products, time, and region. The retail industry requires the timely information regarding customer needs, product sales, trends, and fashions, as well as the quality, cost, profit, and service commodities. It is therefore important to provide the powerful multi-dimensional analysis and visualization tools, including the construction of sophisticated data cubes according to the needs for data analysis. Third one, analysis of the effectiveness of sales campaigns. The retail industry conducts sales campaigns using advertisements, coupons, and various kinds of discounts and bonuses to promote the products and to attract the customers. Careful analysis of the effectiveness of sales campaigns can help improve company profits. Fourth one, the customer retention analysis and of customer loyalty. We can use the customer loyalty card information to register sequences of purchases of particular customers. Customer loyalty and purchase trends can be analyzed systematically. Goods purchased at different periods by the same customers can be grouped into sequence. Sequential pattern mining can be used to investigate changes in customer consumption or loyalty and suggest adjustments on the pricing and variety of goods to help retain customers and attract new ones. Next one, product recommendation and cross-referencing of item. By mining associations from sales records, we may discover that a customer who buys a digital camera is likely to buy another set of items. Such information can be used to form product recommendations. Collaborative recommendation system use data mining techniques to make personalized product recommendations during live customer transaction based on the opinions of other customers. Product recommendation can also be advertised on sales receipts in weekly flyers or on the web to help improve the customer services. Next one, fraudulent analysis and identification of unusual patterns. Fraudulent activity costs the retail industry millions of dollars per year. It is important to identify potentially fraudulent users and their typical usage pattern. Second, and detect attempts to gain fraudulent entry or unauthorized access to individual and organizational accounts. Third one, discover unusual patterns that may need special attentions. As another industry that handles huge amounts of data, the telecommunication industry has quickly evolved from offering local and long distance telephone services to provide many other comprehensive communication services. These include cellular phone, smartphone, internet access, email, text messages, images, etc. The integration of telecommunication, computer network, internet, and numerous and other means of communication and computing has been underway, changing the face of telecommunication and computing. Data mining in science and engineering. In the past period, many scientific data analysis tasks uh, were, were executed to handle relatively small and homogeneous data set. Such data were typically analyzed using a formulaic hypothesis, building a model, and evaluate the results. In these cases, statistical techniques were employed for their analysis. Massive data collection and storage technologies have recently changed the landscape of scientific data analysis. Today, scientific data can be amassed at much higher speeds and lower costs. This has resulted in the accumulation of huge volumes of high dimensional data. Vast amount of data have been collected from scientific domains. So we look at some of the challenges about the emerging scientific applications of data mining. The first one, data warehouses and data pre-processing. Data pre-processing and data warehouses are critical for information exchange and data mining. Creating a warehouse often requires finding means for resolving inconsistent or incompatible data collected in multiple environments at different time periods. This requires reconciliation semantics, referencing systems, geometry, measurements, accuracy, and precision. Methods are needed for integrating data from heterogeneous sources and for identifying events. Next one, mining complex data types. Scientific data sets are heterogeneous in nature. They relatively involve semi-structured and unstructured data such as multimedia data and georeferenced stream data as well as data with sophisticated, deeply hidden semantics. Robust and dedicated analysis methods are needed for handling spatial temporal data, biological data, related concept hierarchies, and complex semantic relationships. The next one, graph based and network based mining. It is often difficult or impossible to model several physical phenomena and processes due to limitations of existing modeling approaches. Alternatively, labeled graphs and networks may be used to capture many of the spatial, topological, geometric, biological, and other relational characteristics present in scientific data sets. In graph or network modeling, each object to be mined is represented by a vertex in a graph and edges between vertices represent a relationship between the objects. Next one, visualization tools and domain-specific knowledge. High-level graphical user interfaces and visualization tools are required for scientific data mining systems. These should be integrated with the existing domain-specific data and information systems to guide researchers and general users in searching for patterns, interpreting and visualizing discovered patterns, and using discovered knowledge in their decision making. Next one, data mining in engineering. Data mining in engineering shares many similarities with the data mining in science. Both practices often collect massive amounts of data and require data pre-processing, data warehousing, and scalable mining of complex types of data. Both typically use visualization and make good use of graphs and network. Moreover, many engineering processes need real-time responses And so mining data streams in real time often becomes a critical component. Vulnerability patterns, clusters, and outlay. Intrusion detection systems should have a graphical user interface that allows security analysts to pose queries regarding the network data or intrusion detection results.